So in this session we're going to talk about drainage, in particular above ground drainage, which is the drainage systems that you will find inside a building, be it a domestic house or a commercial building. Okay, so we're using the illustrated guide to hot and cold water services with this topic. So we normally have drainage associated with sanitary ware such as basins, sinks, baths, showers, etc. There's a connection. Typically at that connection we have what we call a trap, which is essentially a U-bend. Then we have a horizontal branch which then connects from that trap and runs at a slight gradient to allow the effluent or the wastewater to flow away from the appliance. And then that connects into a vertical stack which then drops down below ground, and therefore we call that below ground drainage, which is dealt with in another topic area. So above ground drainage is everything above ground level, so it's all the drainage you can essentially see, and it's normally undertaken by a plumber on a contract for a domestic house, and the plumber would also do the drainage for a commercial building. Okay, so the first thing is to look at the traps and understand why we need them. Essentially, their main job is to prevent smells from a drainage system entering into the house. Obviously, with effluent, there are going to be gases given off, and we don't want this to come into the house and ruin our environment. So these traps create a water seal, and that means that the effluent smells and gases then are kept at the far end on the right hand side of this trap. The water prevents those smells from progressing into the room, the bathroom or the kitchen. Sometimes you may experience a bad smell in the house, and that's because the trap is no longer filled with water, and the gases from the sewerage system is allowed to pass through that and into the room. So we need to understand how to maintain the water seal in that trap. Those traps and these U-bends, they come in different shapes and sizes, S-traps, P-traps for example. Even toilets have a basic form of trap as well. And as you can see here, there's a relatively short depth of trap in the toilet, but because of the fairly large diameter, that amounts to a significant amount of water, or fairly significant amount of water being used to prevent the smells coming through. The problem occurs when the water can evaporate from this trap, and that's if the appliance hasn't been used for a while. You often find this if you have an ensuite bathroom at home that is not used very often, and the water in the trap evaporates typically from the shower tray, and therefore the smells start to come in. There are obviously other reasons why that trap can be replaced or the water not being there, and that's because of the gradient of the pipe can be too steep, and that causes something called siphonage. It can also be affected by adjacent appliances, so adjacent showers or baths or toilets can affect the drainage in the system, again causing what we call induced siphonage. And then we have things called other issues called wavering out, where the wind over the top of a drainage stack can affect the pressures in the system. So there can be a variety of reasons in terms of how we can lose that water seal. Pipework materials then, generally plastics have replaced the use of the metal pipework, particularly for above ground drainage. Cast iron used to be used and is still used occasionally in commercial buildings, particularly where it's a high-rise building and there's concern about the pressures in the system. There might not be much faith in plastic drains when you're dealing with a large amount of fluid coming down a drainage pipe. So very much depends on the engineer whether they use plastics or cast iron. Okay, so what we see here in this diagram is gravity drainage system, and if you look at the on the left hand side here, I'll just zoom in, we can see that we have a number of appliances. We've got a bath, wash hand basin and toilet connected into our stack. So this is our vertical stack. This is our soil vent pipe. So this is the dry part of the stack here, and that goes up to typically up to the roof where it's vented. Just imagine that this is like a straw, okay, and there's fluid going down here. If you cover the top of this, or if it's not left open, if it's sealed, then the fluid will not be allowed to travel downwards. So we need to allow this to be open, and therefore there's no suction pressure, and then the effluent can follow gravity down to the below ground drainage system. What's important when we're dealing with these type of systems is to ensure that first of all we have the right gradient for the horizontal branches, and also the distance from our furthest appliance, such in this case our bath, to our vertical stack. So we need to take that into account. If we get these things wrong, it's going to have an adverse effect with our drainage system, in particular the traps. If these distances are too long, then it can create suction pressure, and that can suck the water from the trap, and then that'll allow smells to come into the building. So there's quite a lot to consider when we're dealing with drainage systems, and if you get it wrong, the penalties are basically bad smells in the inside the property. Here we can see we have a stack for the wash hand basins and bath, and a separate one for the toilets. Okay. In certain cases, you can see in this middle example, this is not going to the roof, and instead this uses a special piece of equipment called a air admittance valve, AAV. Some people in the trade will call this a Durgo valve, and that's after the name of a manufacturer of these air admittance valves. And these are basically one-way valves. They allow air in, but they don't allow air out. So they can be used in certain applications where buildings have a certain height, and it means that you don't need to extend the drain up to the roof. So pretty handy, particularly if you're in an awkward position in the property and you can't get to the roof. So as I said, there's a slight fall in the direction of the soil stack, and typically the gradients you're looking about 1 in 40 for a domestic application, and that would mean that for every 40 meters you travel horizontally, there is a 1 meter drop. So it's a very shallow gradient, and as I said, if it's too great or too long, then there's a possibility of suction, and that can suck the water from the trap. This table here now gives you an indication of lengths, sizes and gradients. Okay, and normally what you'd encounter on site is that the builder would use a level when they're setting up the drainage gradients, and they will have a position marked on their spirit level as to the right gradient. It's not very accurate, but it can work in small applications. But the proper way to do it is to measure it, and you can use a bit of trigonometry to do it, which is fairly simple exercise to do. Here, this is what an air admittance valve looks like. This is a 4-inch drainage stack. So this is a dry part of the stack. Here's a connection, looks like, from a toilet and from wash hand basins here. So this would be the wet part, and it's going below ground or continuing down through the floor. But this is a dry part of the stack where the air is, and this just allows air into the stack. It does not allow the smells out. Okay. There are, just before I move on to pump drainage, there are other types of systems we can utilize. This is the single stack drainage method, which is the simplest one we can have, the cheapest as well. We have it in most domestic houses and in quite a lot of commercial buildings. But if we can't work to these gradients for various reasons, or if the wash hand basins are too far away from the stack, sometimes that can happen in a commercial building, then we would need to upgrade our system, our drainage system here. Instead of a single stack, we would have to use what we call a vented stack system. So there might be 2 stacks then, one for carrying all the effluent, another one which deals with alleviating air pressure in the system. So if you look in your guidebooks under the vented drainage systems, you'll be able to read up more on that. But they're obviously more expensive, so we try to use a single stack wherever possible. Okay, in certain applications, and typically at domestic areas, we can utilize what we call pump drainage, and this is where the effluent is captured in this box. We have a macerator in there, which basically breaks it all up into liquid form and then pumps it in a smaller pipe, and it can, instead of falling at a gradient, it can actually take it vertically upwards. The problem with pump drainage systems is that it requires obviously a pump. These pumps can break down, and you're putting the pipes are under pressure there, under a higher pressure. So we need to make sure that there's no blockages, because otherwise the pipes can burst open. The same applies on a commercial system. We can have pump drainage systems, so we call them pumping stations. Again, similar type of approach. Instead of just having a small box at the back of a toilet, we'd have a large chamber with a large submersible pump in there, and it'll basically take the effluent and rise it up to the various floors. That's particularly useful when we have drainage in a basement area, and that basement area is at a lower level than our sewer outside, so we'd need to pump it up to the sewer. However, try to avoid these, because there's just another piece of maintenance work we need to look after. Rainwater harvesting, then we're moving away from, I suppose, the effluent and foul water, and we're moving more onto rainwater now, and there's a variety of systems here that we can use to save money and reuse the water instead of using mains water. I'll talk about that in our next recording.